So then potassium permanganate we are going to see. So what is the potassium permanganate formula? KMnO4, right? Okay. So it is unstable acid. It's not a salt, it's an acid. Okay, salt only, but we can say it's an unstable acid. Okay. So what is its oxidation state? It is +7. No, right? Potassium permanganate is obtained from a ore called pyrolucite. Pyrolucite. Okay. So I'll explain you how it is converted from pyrolucite to potassium permanganate. Okay. So when manganese oxide, write this conversion of pyrolucite to potassium manganate. Not permanganate. First, it is converted into manganate. Like we saw potassium chromate to dichromate, right? Both are interconvertible. Like that, here also manganate to permanganate. Okay. So it should be reacted with potassium hydroxide. Okay. Manganese oxide reacts with potassium hydroxide. It gives K2MnO3. What is it? Potassium manganate. Potassium manganate. Okay. Plus 4H2 twice. Okay. Then this potassium manganate 2K2MnO3, it again oxidized to become potassium permanganate. O4 is per. Yeah. No. That is completely different. I'll explain you that. In the form of electrolytic process, I'll explain you that. So this is what the pyrolite is converted into potassium manganate. Okay, and then potassium manganate to potassium permanganate. Permanganate. Now you know the formula for potassium manganate and potassium permanganate. We'll discuss about the structure later. Okay. So this is what given. Suppose if you're asked to write the preparation, you can write like this. Okay. So that conversion of potassium manganate to permanganate, it involves lot of chemical method. Okay. In your book only electrolysis process is given. There are two methods. One is normal chemical method. Another one is electrolytic method. Okay. Shall we discuss about that? So this manganate to permanganate. Potassium. Okay. It involves first method is chemical method. This is the preparation process. Okay. From its ore, pyrolusite means MnO2, manganese oxide. Okay. So from the pyrolusite, this potassium is now added. That means from the alkali, now we are getting potassium manganate. Now the potassium manganate is converted into potassium permanganate easily by oxidizing. So we put only the reaction easily. Okay. What we did? KMnO3 plus O. It gives KMnO4. It will not take some easily. It involves this process. First one is chemical method. In the chemical method, CO2 is fast. Do write this. The fused dark green mass. Okay. So for the chromate and all, reddish orange, then orange. Okay, if it becomes acid, then it chromic acid, then it becomes yellow. Another one, yellow mass we've learned. What is that yellow mass? Last sodium dichromate. Okay. So here you will be getting the fused dark green mass. Do write this. The fused dark green mass is extracted with a small quantity of water. The fused dark green mass is extracted with a small quantity of water. Then the filtrate is warmed and treated with a current of ozone. The filtrate is warmed and treated with the current of ozone. Okay? Ozone, chloride, or carbon dioxide. Okay? Then potassium manganate gets oxidized to potassium permanganate. So this oxidation process will take up all these reactions. It won't easily mix up with oxygen. The remaining hydrated manganese dioxide, it precipitates out. It settles down. Precipitated means it settles down. So what happens when CO2 is passed? First of all, we've learned the fused dark green masses mixed up, extracted with a small quantity of water. So what is the filtrate we get? 2KMnO4 plus MnO2. It is a precipitate. Okay. Plus 4KOH. Okay. It is manganate. It is permanganate. Sorry. It is manganate means 3. Right. It is permanganate. Is it clear for you? Then 2CO2 plus KOH. It gives 2K2CO3 plus H2O. Okay. When chlorine or ozone is passed, then what happens? When chlorine or ozone is passed, then so do parallelly check with the balanced elements, okay, in the reaction. So 2K2MnO3 plus Cl2, it gives 2KMnO4 plus 2KCl. Okay. So 2K2MnO3 plus ozone plus water. It releases 2KMnO4 plus 2KOH plus oxygen. Now the oxygen is gas, it is evolved outside. Okay, just how the manganate become. Potassium manganate is converted into potassium permanganate. By chemical method. Got it, Paul? So, so this is the purple solution. This is the purple solution. Which one is dark green color? That pyrolusite. That means the oxide, MnO2. This precipitate is green color. Now you are receiving the potassium permanganate. It is purple solution. So dark purple color. So it is looking like a dark needle crystal. Okay. So needle-like crystals. Okay. So its property also discussed in your book, right? Having metallic luster. Yeah. So you need to learn all those things. Then the electrolytic method is discussed in your book. So next method is electrolytic method. What is the electrolytic method? K2Mn O3 is now oxidized electrolytically. Okay. So at anode, what happens? What is the reaction given in your book? How the green becomes purple at the anode and at the cathode. We saw, right? So what is happening at the anode and at the cathode? Hmm? What will happen? 2Mn over 2 minus, it gives 2Mn O4 minus plus 2 electron. So it is green, it is purple. This reaction is briefly discussed in your book. 2H plus 2 electron, it gives H2 gas. That's all we saw in this, right? Okay. So how it gets crystallized? There we saw potassium dichromate is crystallized by allowing it to cool. Okay. Initially, it is like a hard solution. Okay. How it is settled as a crystal? By means of evaporation. Okay. Cooling also leads vapors and evaporation. Okay. But here, the more highly evaporated, then it becomes crystals. Okay. So, in your book, what it is given? So, this is what discussed in this. So, first of all, MnO2, it becomes MnO4 2 minus, right? Manganate ion. Then it releases 2 electron, right? 2 MnO4 minus plus 2 electron it releases. Is it clear? This is oxidation, right? So we saw in the presence of the alkaline solution. Then, yeah, in lab, something it is given manganese 2 ion salt is oxidized by peroxo disulfate to permanganate. This is also one reaction given in your book. What is it? 2Mn2 plus what is this? S2OA 2 minus is peroxo disulfate. Peroxo disulfate. Peroxo means 8 oxygen, right? Okay, because it is given disulfate. Okay, so 2 sulfate. Okay, so it is oxidized to form permanganate. Okay, permanganate is there, right? Okay, then 10SO2 4 minus, then 16 plus. This is an ionic equation for this. Is it clear for you? Okay, then potassium permanganate. Okay, this is given as a thing. Actually, two structures are discussed over here. The physical properties of your interest, you can learn all these things. Diamagnetism. Okay, you know that, right? So it is temperature dependent, especially. It shows only weak paramagnetism. Okay, these can be explained by the use of molecular orbital theory. You know, right? But it is not of your scope right here. Okay. So what is the tetrahedral? Both are in tetrahedral nature. What is the missing thing? Here and all, the pi bond is missing in this. Okay. You know, if there is double bond, one should be single sigma bond, another one is the pi bond. So when compared to no, double bond means one is sigma, that is S to P, another one is P to P. That is, this is pi bond. This is lateral shape. Okay, pi bond. And then this one is sigma bond. Suppose if there are three bonds, one is sigma, this is pi, this is pi. So two pi's and one sigma. Pi bonds are maximum unsaturated, right? Here you must find the three pi bonds, right? Okay. And compared to this here, one pi bond is receipt. That is a major difference. That pi bond can be occupied by means of what? Oxidation or reduction? Oxidation. What part of? Okay. You listen. Then so many oxidation reactions are takes place in this. Here also you'll be given. So what type of reaction it is? Is since it is the oxidizing agent or reducing agent? Huh? Reducing agent. Reducing agent means it reduces itself, right? It oxidizes. Yeah, it oxidizes itself. So what is the meaning of oxidation? So here also it is given acidified potassium, sorry, acidified permanganate solution. It oxidizes, oxalates into what? Oxalates to carbon dioxide. Then iron 2 to iron 3, nitrites to nitrates, and iodides to iodides, like that. Iodides to free iodine. So as usual, we saw, right? So what about the half reaction here? This is the half reaction. Okay? If it shows oxidize means what is the meaning? It should lose electron. Right? This is oxidation half reaction, right? Write in your notebook. This is an oxidation half reaction. So what is that? 5 COO minus COO minus. What is this? Both H plus. Okay. So it oxidizes, oxalates. This is an oxalate, right? In an oxalate, you might have seen in alkyl groups, two COOH is attached, right? So the oxalate is now reduced to carbon dioxide, okay, by releasing 10 electrons. Then Fe2 is now reduced to Fe3, sorry, oxidized. Fe2 is now oxidized to Fe3 by releasing 5 electrons here. Okay, because 5 Fe2 plus, it releases 5 Fe3 plus. Since Fe2 plus, it is not directly converted into Fe3 plus alone. Should be involved in the reaction. You'll be given only the ions, ionic representation. Okay, it is involved in the reaction. So potassium, sorry, that acidified permanganate only helps this kind of oxalate to carbon dioxide, iron 2 to iron 3. So it needs 5 number of ions. Okay, so minimum. So 5 Fe2 plus, it becomes 5 Fe3 plus 5 electron. Then NO2 minus oxidized to NO3 minus nitrates to, sorry, nitrites to nitrites. This is nitrite. This is nitrate. Okay, by mixed up with water. Then iodide to free iodine. So all the half reaction is given. As you know, the full reaction can be written by adding the half reaction for KMnO4. You know that, right? So as per I've taught you like potassium chromate, right? Potassium dichromate. Then you have added the half reaction. Then you know the full reaction now, right? And then you must know how to write the ionic equation also. Okay, take it as an assignment. Okay, for writing all these things. You must write all the reactions in the full form and then do summative. Then if we represent the reduction of permanganate to manganate, so it is also interconvertible, right? Once if it is oxidized, it can also be reduced. Okay, permanganate to manganate. So manganese oxide and manganese 2 salt by half reactions. Manganate, manganese dioxide, manganese 2 salt by half reactions, it can be reduced. Permanganate can be reduced to manganate by 1/2 reaction. That what is that half reaction? That is reduction reaction. Right? So what is the electrode potential mark? 0.56 volt. When it reduced to manganese dioxide, what is the standard electrode potential? 1.69 volt. When it is reduced to manganese 2 salt, this is known as manganese 2 salt, since it can produce salt with some other thing. Manganese sulfate, manganese chlorate, like that. Okay. So then what is the standard potential? 1.52 volt electrode potential. Since it is reduction process, right? All the electrode potential is in positive, plus. So hydrogen ion concentration of the solution plays an important role in this reaction. Okay. So clear for you. So total redox reaction, you must know about all these things. What is permanganate at H plus concentration? It is 1. You know, right? 1 H plus is the concentration of H plus will be always 1 in permanganate. It should oxidize water, but in practice, the reaction is extremely slow. Unless either manganese 2 ions are present or the temperature is raised. So it's oxidized process. If it oxidizes water, it's readily slow. So it needs to be mixed up with manganese 2 ions, or you need to raise the temperature. These two are very important since it is very slow process. Okay, then if you important oxidizing reactions also given, what is the reactions in acid solution? It is given. So all the ionic equations mentioned over here, you have to write from the half reaction. Can you able to know this? So I taught you clearly in the first one, potassium, manganate to permanganate, right? We know everything. So based on that, you know how it is reduced here, how it is oxidized here, how the manganate becomes permanganate. You know everything, right? Based on that, you need to write all the ionic reaction. Can you? Okay. So that's all. What are the uses it is given? It is used as a favorite oxidant in preparative organic chemistry. We can use it as an oxidant, okay, mainly. So because it is easily reduced and oxidized, right? Can easily remove electron or add electron. By means of electrolytic reduction only, electrolytic process only, in your book, the portion is given. But I've taught you about the chemical method also. We have discussed earlier, right? So you must think of it that also. If you are asked questions in that manner, you have to write the chemical method. Okay. So here what is given? It is used for the bleaching of wool. What is wool? You know, right? Okay. So cotton, silk, okay, and other textile fibers, and for the decolorization of oils also. Okay, are also dependent on its strong oxidizing power. This is the major use of this particular permanganate. You can also use for titration also, right? So potassium dichromate and permanganate, it is the famous compound in D block elements. Bye-bye.
Wait. Alright. Thank you so much for watching. If you guys enjoy it, make sure to subscribe to my channel. Subscribe to my mom's channel. Bye.
Okay.